For centuries, black holes have existed at the edges of our imagination, terrifying, enigmatic voids that defy the laws of physics as we know them. They were theoretical concepts, woven into the fabric of Einstein's relativity and Stephen Hawking's groundbreaking work. But for most of human history, black holes were a mystery, something to fear, something to theorize about, but not something we could touch, see, or truly understand. And yet, in the vast, incomprehensible expanse of the cosmos, there was always the quiet promise of discovery. The idea that, one day, we might uncover the truths hidden in the darkness. On April 10, 2019, the unthinkable happened. Humanity took its first real step into the heart of a black hole, capturing the very first image of one. A glowing ring of light, an unfathomable void at the center of a distant galaxy. This achievement shattered our expectations and challenged everything we thought we knew about the universe. But what led to that monumental moment? How did scientists overcome the unimaginable obstacles that stood in their way? The image that rocked the world wasn't a simple photograph. It was the product of decades of collaboration, of sacrifice, of persistence. The effort to capture it was not only a triumph of technology, but a testament to human ingenuity and the relentless drive to understand the cosmos. At the center of this achievement was a global network of scientists and engineers, the Event Horizon Telescope (EHT) collaboration, a collective effort that spanned continents, cultures, and disciplines. The mission required the collaboration of over 200 scientists from 60 institutions across the world, from the snowy reaches of Antarctica to the deserts of Chile, from the volcanic islands of Hawaii to the jungles of South America. This team was not simply bound by geography. They were united by a shared vision, a belief that the impossible could be made possible, that the universe could be understood in ways never before imagined. What they were trying to achieve was nothing short of extraordinary. A detailed image of a supermassive black hole, a cosmic giant sitting at the heart of the galaxy M87, more than 55 million light-years away. A black hole whose gravity is so powerful that it bends light, making it invisible to traditional telescopes. How could one possibly capture something that literally swallows all light and matter in its grasp? The answer came in the form of very long baseline interferometry, VLBI, a technique that allowed telescopes across the world to synchronize in real time, creating a single, Earth-sized observational tool. By linking radio observatories as far apart as Antarctica and Hawaii, the team essentially created the most powerful telescope ever constructed, one capable of seeing details smaller than the size of a tennis ball on the moon. But even with this level of power, the task they faced was incredibly daunting. The distance between Earth and M87 was so vast, the black hole itself so faint, that the data needed to create an image was unimaginable in scale. Petabytes of information, all of which had to be gathered, transferred, and analyzed. Every step of the way, the team was confronted with obstacles, from data corruption to technical failures, but the goal always remained clear: to witness the invisible, to make the unknowable visible. The journey was filled with uncertainty and heartache. The team wasn't just battling technological limits, they were fighting against the very nature of the cosmos itself. When the data was collected, the first challenge was simply getting the information from the telescopes to the data centers. Some of the data came from remote locations where the logistics of transferring terabytes of information could take weeks. The stakes were enormous. What if the data was corrupted? What if the faint signal they sought was lost in the noise of the universe? What if they could never see the black hole at all? There were moments of doubt, moments of frustration and despair. The team was running algorithms, processing information, checking and rechecking. Each mistake, each misstep could have meant failure. And yet, despite the mounting pressure, the scientists pressed on. It was a journey not just of intellectual rigor, but of emotional endurance, of pushing through failure after failure in the hopes that, eventually, they would reach the breakthrough they so desperately sought. And then, after years of struggle and uncertainty, the breakthrough arrived. On that fateful day in April 2019, the world saw the first ever image of a black hole. The ring of light that emerged from the data wasn't just an image. It was a message from the cosmos, a cosmic truth that had eluded us for centuries. It was the shadow of the event horizon, the point beyond which nothing can escape. The image confirmed that black holes are real, and it showed us, for the first time, a glimpse into a universe that operates beyond our understanding. The black hole wasn't just a theoretical concept anymore. It was tangible and it was real. But what did this image mean for science? And, more importantly, what did it mean for humanity? The implications were staggering. This image wasn't just a proof of concept. It was a triumph of human ingenuity, a demonstration that when we come together, when we dare to imagine the impossible, we can achieve the unachievable. The black hole's image confirmed Einstein's theory of general relativity in a completely new environment, an environment so extreme that no theory had ever been tested to such a degree. It opened new doors to black hole physics, deepened our understanding of space-time, and further revealed the profound mysteries of the universe. It was a victory not just for physics, but for humanity, for the collective spirit that drives us to explore the unknown. But it wasn't just the science that made this moment unforgettable. The team behind this discovery wasn't just a group of scientists. They were dreamers, passionate individuals who had dedicated their careers to the pursuit of understanding, who had fought against the odds to make this moment a reality. For Dr. Heino Falk, the Dutch astronomer whose vision guided this monumental project, the victory was both personal and professional. He had spent years pushing the boundaries of what was thought possible. But like every member of the team, he had to grapple with doubts, challenges, and setbacks. Yet through it all, he and his team never gave up. They were fueled not by certainty, but by the desire to explore, to learn, to understand. The emotional weight of this success was profound. For the scientists and engineers who dedicated years to the Event Horizon Telescope, the moment the black hole image appeared on their screens wasn't just the culmination of their work. It was the realization of a shared dream, a dream that transcended borders, cultures, and languages. It was a reminder that in our quest to understand the cosmos, we are all connected, part of a larger human story, one that is driven by curiosity, wonder, and the relentless pursuit of knowledge. And so, as the first black hole image took its place in the annals of scientific history, we were reminded that the universe is full of mysteries, mysteries that we have only begun to uncover. The first image of a black hole is not the end of the journey, but the beginning. It is a testament to human potential, a glimpse into a future where the stars and the very fabric of space-time are no longer beyond our reach. What lies ahead is still unknown. What other truths, hidden in the farthest corners of space, will we uncover next? The first image of a black hole is but one small piece of the cosmic puzzle. There are more questions to answer, more wonders to explore. And as we look to the stars, we can take heart in the knowledge that the spirit of discovery, the drive to understand our universe, will carry us into the future, one breakthrough at a time.